Hi, I am Ms. Warnow, and we are going to begin the unit on the mole. I would like for you to have out your periodic table, a piece of paper, as well as a calculator so that you can follow along as we work problems for this unit. So what is the mole? We sometimes use words to represent a specific number of items. We talk about a pair, we know that means 2. We talk about a dozen, and you know it means 12. And then gross, you may not know this, but it's a dozen, so 144. In chemistry, we use the term mole to represent a really huge number, and that number is 1 mole is 6.02 times 10 to the 23rd particles. And it's a really big number, and it's really big because what we're using it for is to count atoms and molecules. And these are very small, so it's going to take a lot of them to get a good count on. So how did scientists come up with this number, 6.02 times 10 to the 23rd? It started with the atomic masses for the elements. For example, carbon has an average atomic mass of 12.01 AMU, that stands for atomic mass unit, meaning that one atom of carbon has a mass of 12.01 AMU. The scientists wanted to be able to use the convenient atomic masses for the elements, but on a larger scale. So they decided to keep the numbers all the same, just change the unit, and so we used 12.01 grams of carbon. It's the same number, just a different units. We're going to use grams instead of AMU. We know that one atom of carbon is equal to 12.01 AMU of carbon, but how many atoms of carbon are in 12.01 grams? This is the number that's been experimentally determined to be 6.02 times 10 to the 23rd atoms. This is also known as Avogadro's number. It's named after Amedeo Avogadro, who is best known for his experiments with gases. Move this out of the way. So 6.02 times 10 to the 23rd particles would be Avogadro's number, which is equivalent to 1 mole. What this means is that the unit on every atomic mass on the periodic table can be changed from AMU to grams. And that mass in grams will give you Avogadro's number of that element. This is known as the molar mass because it is the mass of 1 mole of that element. Particles. What do we mean when we say 6.02 times 10 to the 23rd particles? Well, particles could be atoms, it could be molecules, it could be formula units, it could be ions. So when we talk about an atom, this is used to describe individual particles of an element, such as helium, copper, and sulfur. A molecule is used to describe the particles of a molecular compound. It can normally contain a non-metal metalloid, or it could be a diatomic element. Okay, so examples of molecules would be carbon dioxide, phosphorus trichloride, water. Those are molecular compounds. But these elements here never are by themselves, so they always pair up with one another. So these are called diatomic, and they're hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. You are expected to know those. And so they can also be formula units used to describe the lowest ratio of 2 ions in an ionic compound. So you have sodium chloride, potassium nitrate, and silver phosphate. And you can also talk about in terms of ions. This is barium phosphate. Okay, and we'll talk a little bit more about ions in a bit. And in any reaction that we are performing, there are huge numbers of particles reacted, so we need a way to count these, and that's where the mole comes in. We'll use 6.02 times 10 to the 23rd, or you can see it on your other resources as 6.022 times 10 to the 23rd. It wouldn't matter which one of these you use because they're only off by 2,000, so either one of those are acceptable. And so since the substances are so small, it's helpful to group them in numbers that are more manageable, and that's where the unit mole comes in. So let's work some problems. So like I said, you should have your periodic table, you should have a sheet of paper, and you should have a calculator. And guess what? We get to go back and use our dimensional analysis skills that we learned at the beginning of the school year. So this is how many moles of copper are in 1.7 times 10 to the 24th atoms of copper. So we need to write down our given 1.7 times 10 to the 24th atoms of copper. And since we're going to want to cancel out atoms, it's going to go on bottom. And we want to get to moles. We do know a relationship between moles and atoms, and it's that 1 mole is equal to 6.02 times 10 to the 23rd. And these will cross out, and we're left with moles of copper, which is what we would like. And so when you punch this into your calculator, and I recommend that you actually pause and punch this into the calculator and make sure that you are getting 2.8 moles of copper. Okay, and notice this has 2 significant digits. That has 3. I have 2 in my final answer. How many atoms of gold are in 2.5 moles of gold? So we start by writing down our given, which is 2.5 moles of gold. And since we want to get rid of moles and end up in atoms, since that unit's on top, we're going to need to put it on bottom. And we do know relationship between moles and atoms. And it's that 1 mole of gold is going to be equal to 6.02 times 10 to the 23rd. Notice that not only am I writing the unit, but I'm also writing the substance. So be sure to show all of this work when you're doing practice problems in class. So when you punch that into a calculator, you get 1.5 times 10 to the 24th atoms. Notice I put the unit of gold, and I also put what the substance is. So this had 2 significant digits. I have 2 here. I listed the unit, and I included the substance. I also included these units and substances in my work as well. How many moles of water are in 3.01 times 10 to the 23rd molecules of water? So we start by writing down our given, 3.01 times 10 to the 23rd molecules of water. We want to get rid of molecules, so we'll put it on bottom so it will cross out. And we do know relationship between moles and molecules. It's that 1 mole is equal to 6.02 times 10 to the 23rd molecules. That crosses out. And so when you punch this into your calculator, you do 3.01 EE23 times 1 divided by 6.02 EE23, and you should get 0.498 moles of H2O. Once again, this has 3 significant digits, 3. I put my unit, and I wrote my substance, and I included all of those along the way as well. You're expected to show good work here. I pause the video and go ahead and take a moment. So when you look, we wrote down the given here. Notice the unit and the substance. We want moles to cross out, so it goes on bottom. And 1 mole is equal to 6.02 times 10 to the 23rd formula units. And this should be your answer. And then you need to make sure NaCl. There you go. All right. 1 mole is also equal to the molar mass in grams. So how does the mole relate to mass? So just think about this. Does a dozen eggs have the same mass as a dozen cars? So does 12 eggs have the same mass as 12 cars? We know it does not. We know the cars have more mass. Does a pair of shoes have the same mass as a pair of earrings? We know that they do not. So a mole of helium is not going to have the same mass as a mole of carbon. Okay? And we're talking about mole, we're talking about 6.02 times 10 to the 23rd. We can look on the periodic table and look at the masses of helium and carbon and see that they are different. We call the mass of 1 mole of a substance its molar mass. So where do we find the molar mass of an element? You find that on the periodic table. This is why you needed your periodic table with you when you're watching this video. All right, so what you'll do, it says phosphorus here, find phosphorus on your periodic table. And we're going to talk about 1 mole of phosphorus. We know that 1 mole of phosphorus, is equal to 6.02 times 10 to the 23rd particles. But what is that molar mass? So you look on your periodic table, actually look at it right now, and when you look at it, you'll see it's 30.97 grams per mole because it's 30.97 grams of phosphorus for 1 mole of phosphorus. Find aluminum on your periodic table. Actually find aluminum right now on the periodic table. 1 mole of it we know is 6.02 times 10 to the 23rd. But is that going to be, is its molar mass more or less than phosphorus? Well, find it, and when you look at it, it's 26.98 grams per mole. Find silver. Remember, silver is Ag. 1 mole is 6.02 times 10 to the 23rd. Its molar mass is 107.87. This is the unit for molar mass, and you are expected to use it. Now we can convert between grams and moles of a substance by using the molar mass. Remember, the main goal here is that we need to know how many particles we have in a given amount of substance. It's important when we do this later in chemical reactions. All right? So let's work a few of these. It says how many grams of silicon are in 5 moles of silicon. So 5.0 moles of silicon. For every 1 mole of silicon has a mass, and you will need to go physically look this up on your periodic table, and it's 28.09 grams of silicon. And so when we multiply 5 times 28.09, we get 140 grams of silicon. Okay? How many moles of potassium are in 136.9 grams of potassium? Okay, we want to get rid of grams, so it goes on bottom. We're trying to get to moles, so moles would be on top. This relationship is that 1 mole is equal to the molar mass, and so we go look on the periodic table, go physically look at your periodic table for potassium, and you'll find it's 39.10. Let's cross out. And so we multiply 136.9 times 1 divided by 39.10. We get 3.501 moles. Okay, that's 4 significant digits because we had 4 right here. Okay, so putting it all together, so if you know that 1 mole equals 6.02 times 10 to the 23rd, you know 1 mole equals the molar mass, you should be able to go between these by always getting to the mole. Okay, so how many atoms of argon are in 87.6 grams of argon? So you start at 87.6 grams. You want to get rid of that, so it brings down here. You know a relationship between mass and moles, so we'll go there. And that relationship is that 1 mole is equal to the molar mass. So where do we find the molar mass of argon? From the periodic table. And now we're in moles, but we want to be in atoms, so we just draw brackets again. We want to get rid of moles, so it goes on bottom. And now we can get to atoms. And the relationship between moles and atoms is that 1 mole is equal to 6.02 times 10 to the 23rd. And so those cross out. And so we multiply everything across the top and divide it by everything across the bottom. You should get 1.31 times 10 to the 24th atoms of argon. Okay. What is the mass of 5.6 times 10 to the 24 atoms of aluminum? You should pause the video and work this. Okay, and so you'll see here, broke down the given, and we wanted to cross it out. We can go from atoms to moles. That's this idea here. And then we can go from moles to mass because we know that 1 mole is equal to the molar mass. Okay, that concludes video 1. Be sure you took in-depth and high-quality notes. Have good example problems in your notes, and we'll see you in class tomorrow.